Okay, all right, guys. So questions 4 and 5 have to deal with the dilute formula. The dilute formula basically says, see if we can put it right here, maybe. Uh, Molar concentration times volume equals the molar concentration of your new solution and the volume of your new solution. So really, concentration of the first solution times the volume of the first solution equals the concentration of the second solution, or the new solution. So can you see that? Yeah, you can barely see it, but you can see it. Uh, Times, what was I saying? Oh my god. Concentration of the initial solution times volume of the initial solution is equal to the concentration of the final solution times the volume of the final solution. There we go. Oh my god. So, in the first part of number 4, A, a student wants to make 100 milliliters of 0.3 mole of HCl. How many milliliters of 6 mole HCl of m mole? Molar concentration. There we go. HCl is needed to make this solution. So we make a little setup. M1 V1 equals M2 V2. In this case, a student wants to make 100 milliliters. That's gonna be our second volume. Now, it's in milliliters, so we gotta use liters. 100 over 1,000. So converting milliliters to liters. 100 milliliters is 0.1 liters. So this is 0.1. This is going to be in liters of 0.3 mole of HCl. That means I got 0.3. That's the concentration of the new. That's the one he wants. Okay, and now he wants to know how many milliliters, or so what is the volume of the concentration 6.0 m HCl. So m is going to be right here, 6.0. Okay, they're asking for it in milliliters. So after we find out our number, we're going to have to, again, change it to milliliters. Now, if we do 0.3 times 0.1, trust the calculator, we have 0.03. So our 6V equals 0.03. Then, the little algebra, 0.03 over 6, plug that in, divided by 6, and you should get 0.005. Really, 0.005 liters. But they want their answer in milliliters. So we gotta multiply times 1,000. Okay? Because that's how many milliliters there are in a liter. So 0.005 times 1,000 is gonna be 5 milliliters. So here for this one, it's going to be 5 milliliters. Final answer. In part 2, what volume in milliliters? Again, dang, with the milliliters of 15.7 m, or concentration, of hydrochloric acid aqueous solution must be used to prepare 10 liters of 0.7436 mole, or molar concentration, of hydrochloric acid. So they want volume, so initial volume. So B1, that's what we're going to know. 15.7 is the concentration, the initial concentration. So 15.7 V is equal to what we want, 10 liters, which is my V, and 0.7436, which is my M. 0.7436 times, where's that? 10 liters. There we go. Okay. There we go. So multiplying 0.7436 times 10, we've got 7.436. 15.7 volts. Volts? What the heck? Volume. 15.7 initial volume times initial volume equals 7.436. We divide that. Again, little algebra. We're going to leave that in. No editing over here. 15.7. And we get B is equal to 7.436 divided by 15.7 should give you 0.4736. Remember, these are in liters. 0.4736 liters. But to make it into milliliters, we need to multiply times 1,000. And we get 473.6 milliliters. Final answer. Okay, 473.6. And number 5, we're going to do this one quick. Same thing, but there's going to be an extra step. So if you watched the molar concentration video, we're going to basically do that first for this problem. So they give us a 30 gram of solid, is it 30 or 3? Hold on, let me check. Oh yes, a 3 gram of solid sodium CO3 carbonate. We'll have to fact check that. Carbonate, CO3. Cool. Carbonate was dissolved in sufficient water to make 250 milliliters of solution. A 10 milliliter sample of this solution was then diluted to 100 milliliters. What is the concentration of Na2CO3 in this new solution? Okay, so molar concentration. Remember, we got to find the concentration first. How do I find the concentration? Well, they give us the mass of solid Na2CO3. We need moles first. It's too green on this one. Cha-cha-cha. So 3.0 grams over 1 times our mole. One mole Na2CO3 over, oh my god, the molar mass of Na2CO3. Let's figure that out. Let me see. Sodium weighs 22.99. There's 2 of those. That's going to be 45.98. Plus the carbon, which is just 12.011. Plus the 3 oxygens. Each oxygen weighs 15.999, or you can just round it up to 16. So multiply 16 times 3, and then we add them all up. 45.98 plus 12.011 plus 47.997. Where'd that 47.997 come from? It's 16 times 3. Okay, that gives us 105.99. So now, 105.99 grams Na2CO3. There we go. This cancels out. Grams. So now we've got to divide 3 over 105.99. Okay, that gives us 0.0283 moles. 0.28. Oh no, sorry. 0.0283. Gotta read this calculator right. 0.0283. What's going on? 0.0283. Cool. Can leave it like that. Now, that is the number of moles we've got of sodium chloride, Na2CO3, over the liters. 250 milliliters. Okay, so we need to bring 250 to the liters. So 250 divided by 1,000. That's going to give us how many liters? 0.25. So now we're going to divide 0.0283 by 0.25. Now we're going to get a concentration. First, let me show you right here. This is the division. Our answer to this is going to be our concentration, 0.1132. Okay, that's M. Now, then it says a 10 milliliter sample of the solution was diluted to 100 milliliters. Initial volume, final volume. So 10 milliliters, hold on. Gotta bring that to liters. 10 divided by 1,000, 0.01. So 0.1132 times 0.01 is equal to M times V equals M2 V2. V2 is 100 milliliters or 0.1 liters. Come on. 0.1 liters times the concentration, or the M, of my new dilute. So 0.1132 times 0.01, gives us 0.001132. Dang. Divided by 0.1, and we get 0.011 M. 0.011 M. Let me just make a little space so I can show y'all how we got this. And we got this. So 0.1132 times 0.01 brings us to 0.00132 equal to 0.1 M. We divide, this cancels out. This is going to give us that number I just said, 0.01132. 0.01132 equals the final concentration. Okay, that's it.